Good afternoon. I'm Mohan Kumar. I'm a fellow with Intel. I've been with Intel is the only company I've ever worked for, so I don't have any reference point. I graduated from college and I've been with them for 25 years now. So I work in the data center team on cloud architecture, and I wanted to take the next 20 minutes or so to talk to you guys about what we are doing in terms of innovations in the cloud space. Because I'm going to be touching on third-party, I'll just advance manually, it's not working. So this is the official disclaimer of third-party information. So this was the information that I pulled from a couple of years, but the data is still accurate. The good news for all of us in this room is, regardless of what segment you look at, it's e-commerce or digital advertising, digital video, cloud services, they're all continuing to grow at a tremendous pace. That's the great news. That also means that for OCP, where we are in, that means there's a lot of infrastructure demand that we need to go fulfill. So that is also wonderful news for us. So with that demand, what do we do in here? Before we get in there, let's take a look at how cloud, cloud is not just hardware, it's solutions, right? How cloud constructs a solution together. And if you see if we can map these to what we do in the OCP space. Cloud requires platforms. We have server, storage, and networking projects at OCP that kind of are well matched there. The cloud requires platform level security. They have a security project at OCP. Cloud requires firmware. We have Open System Firmware that comprehends the firmware requirements. Right. Cloud requires manageability. We have a hardware management track that takes care of everything. And cloud requires all of this to be put together. A bunch of servers have to be put together in a rack. And there is a rack and power project at OCP, and then you have a data center cooling and power supply to the data center and so on, and there is a data center facility project. So far so good, everything is nicely matched in terms of what a full solution stack looks like at the cloud side and what an OCP project, the projects are that are in motion. Now let's look at what's happening to the world, right? So the monolithic view of the platform essentially is getting replaced. So these are the current projects. So the monolithic view of the platform is getting replaced by more of a disaggregated platform, right? Because of storage being disaggregated or memory being disaggregated due to CXL, and and then potentially even silicon could be the future of the platform, right? So there's some disaggregation on what you thought of as a monolithic entity. Same thing, right? So there was one controller, that was controlling the platform. Now you can see, if you're going to have disaggregation, then each one is going to be managed separately. So where you have single controllers, you're going to have multiple controllers. You got to deal with that proliferation. And where it was purely about management and efficiency of the management, now there is an equation of sustainability that needs to be comprehended, right? It's not just about, I'm going to use it and then after that I'm done, there is no thought to what happens after that. Now we need to worry about, how do I decommission it? What happens to my systems and servers after I decommission, right? That's part of the equation. And in the previous world, we were only focused on air cooling. So everything, we still talk about racks, but in the immersion cooling world, you have to talk about tanks now, right? Because racks is not the metric of how you fill servers in your, as a contained environment. And then the data center environment, when you think of it, at least in the cloud space, was always these 20 megawatt stamps that people put together. But now there is the cloud, like the public data centers, and there is the edge, which is more the smaller sub 10 megawatt things that could be anywhere, right? So they all have different requirements. So that's the opportunity that exists for OCP and OCP's projects to essentially comprehend all these new and emerging requirements. And I'm going to talk to you about some of the stuff we are doing in all of these new and emerging spaces in, I guess, the next 15 minutes that I have left. Quick agenda. I'm not going to go through this given the short time period. So I'm going to start with one of the OCP projects is OSF, Open System Firmware. And in order to support this, the first realization that we had was that in Intel, we need to be in the business of doing what's minimum to initialize the platform, right? Initialize the silicon, initialize, come up with the socket topology, initialize the memory, the things that are very silicon specific stuff. Once we do that, everything else can be done by other pieces of firmware in the place. So we call this firmware support package, or FSP, and we have actually the last two processors, Cooper Lake and Ice Lake. We have actually made our firmware support package binaries available. They are now available on the Intel GitHub. There is an OCP platform called Delta Lake, and currently we have completed the checklist for doing core boot, which kind of takes FSP and then pairs it up with an open source bootloader on boot orchestrator, I should say. And we are continuing to do the same thing for our next processor, which actually the Sapphire Rapids, which you can see. It's not here in the Experience Center today, but you can see it tomorrow when you go to the Experience Center in the Expo Hall. So the idea is that we will do the core FSP portion of it, and then the orchestration layer could be any of these things. Today the orchestration layer is only one thing, which is UEFI. But in the future, it could be UEFI, core boot, slim boot, or any other bootloader of your choice. So this gives, first of all, it gives flexibility. It opens up much of the code base to open source, and it lets cloud and other folks innovate in the space as well. And there is a talk tomorrow from 3:35 that's going to get more into the details of this session as well, right? In my limited time, I can only touch on these topics. Creating just the firmware support package is a necessary but not the sufficient condition. What we need is also a reference. Somebody needs to provide the boot orchestrator reference, right? This is where I think OSF and OCP can play a big role there. And also, so we want to go back to also doing RAAS, right? One of the key things of BIOS is doing RAAS. And in order for us to do RAAS, we need to change the way we do RAAS because FSP, in order to do RAAS, you need to do what's called the standalone MM. And we are going to be focusing on that at Intel and solving that problem. There is a session again tomorrow from 4:15 that's going to talk more about the details of what that RAAS solution is going to look like. And then the second portion of firmware is the baseboard management controller, or the BMC. So one of the things is that OCP has always been it's possessed here. It's just moving on its own. You have the hardware that's available from OCP now with the OSF and then contributions from AMI. You have the OpenBMC. Now you have access to a full solution there, right? The OpenBMC firmware itself is based on the Linux Foundation's repository, right, for all of us. And Intel reference platforms are actually already based on OpenBMC today and will continue to be so, right? And AMI recently released into OCP the code base for the OpenBMC repository, and we are partnered with them in order to support that. And maybe Sanjoy, you can say a few words on the partnership, if you don't mind. This is Sanjoy Maity. He's the CEO of AMI, who did the contribution, which is the company that did the contribution.
Thank you, Mohan. I don't have the microphone, but I will use my voice. Can you hear me? Yes. Okay. So thank you, Mohan. We did partner with Intel preparing the OSF as well as the OpenBMC tree, and we contributed to the OCP. The reason is OCP is a GitHub of hardware. We needed something to correspond to that GitHub of hardware as a GitHub of firmware, which you can build for those OCP accepted platform. So we absolutely synced with the, thank you. You're welcome. So we are absolutely synced with the Linux Foundation OpenBMC, but we are making a long-term supported tree, which is in a proper cadence with production-worthy version. It is coming to the OCP. That's how we are moving. And just 1 minute or so, Mohan mentioned a lot of innovation opportunities in his previous slides. Open source gives that ability. Open source is for transparency, innovation, as well as moving forward with freedom. So AMI believes that, and AMI, we are moving towards that and presenting all those things. Another thing also, I think AMI will bring all this core boot, all the orchestration layer like core boot, Linux boot, or UEFI, all these things can work on top of FSP as an orchestrator layer. which AMI committed to provide as an open source framework. Thank you,
Thank you,
Mohan.
Sanjay.
Yeah.
Awesome. Thank you, Sanjay. Appreciate that. So switching gears, so I want to talk about OCP platform and CXL memory. CXL has been one of the new technologies that has, promises to change the world as you go forward in terms of, how memory hierarchy is going to work out. So we have a pre-production CXL memory buffer that's based on an FPGA that you see on the left side of the screen. And the pointer that works. Okay. Oh, actually, it works. Okay. And this is our pre-production platform. And I'll just play a quick video at the risk of running out of time. So essentially, we showed this demo yesterday in the future initiatives. But for those of you who missed day 0, this is our platform, basically Sapphire Rapids platforms, first platform capable of supporting CXL. It's showing the memory being plugged in over CXL. BIOS detects it, configures the memory. It should be fairly quick. So we reboot the server with the buffer. The buffer gets detected by Linux OS, and it's too small. I apologize. I can't see it on my desk, so I'm sure you can see it on the screen. When you enumerate, you see that memory showing up, and the additional memory capacity basically shows up as if it's a socket with no cores, right? That's how Linux is handling it right now. You could have done it any number of ways, but that's the way Linux is handling it right now. So, but essentially, there's the proof in the pudding, right? So we can actually have the memory that's not attached to the processor itself. It's attached over CXL, is showing up and configured and working for the first step. And the part that ties this to OCP is that this is a pre-production OCP platform, and this again you can see in the interop demo in the expo hall. So we're excited that we're able to bring an industry first here in terms of showing this demo. So a few other things. So one of the things, yesterday there was a lot of discussion on being able to standardize the RAAS support between outer band and in-band. And again, we are working with the OCP community to bring that standardization by carrying the in-band records in the outer band records also as an encapsulation. So you have the ability to correlate the errors, whether they are from machine check, advanced error handling, which is what AER is, and CXL, of course, is the CXL memory errors. CXL memory error, in full disclosure, is still under discussion with the CXL consortium. So it's not a done deal yet, but we are continuing to work with them. And our goal is to essentially support these, all of these, so there is commonality between what you do in band and what you do out of band, because we have two types of customers, right? One that are very horizontally oriented, that they're consuming their own, they're in control of the OS. Like if you're a social media company, you're in control of your OS, or a search company, I should say, as well, right? Whereas if you're a public IaaS company, infrastructure as a service, then you're running somebody else's, and a bare metal, you're running somebody else's OS. So then you don't get to do that. So we're trying to support those two bookends essentially with a common solution. And again, I'm touching on all these things, but there is a discussion tomorrow again that will go deeper into what this means in terms of the details. And the other thing is, the delivery of a server is not just, we shipped a server and thank you very much, right? It's, from the time the server hits our customer's environment to the point it's deployed, to the point, how do you manage it? How do you update the server? How do you make this is possessed, I tell you, I'm not doing a thing. And how do you manage the security of it? How do you comply? And then now with sustainability, what do you do after you decommission it? How do you take the server and then, waterfall it to either within the company or outside the company? Well, right? All of this is in the scope of what the cloud service model work that our architecture team is looking at. And the other thing is that there is a lot of telemetry that gets collected, right? And you always hear about, the cloud people have a lot of telemetry. And the question may always come up as like, if they have all this telemetry, why don't they just put it out there so we can all analyze it. Well, there's a few reasons why they don't do that, because it's got lots of vendor information embedded in there. It could have vendor information from all the silicon vendors, all the drive vendors, all the fluid vendors, right? You don't want to put it out there. And the other thing is that the data is identifying in terms of which location, which geography that these servers are deployed in their environment. They don't want any of that coming out of their environment, right? So the work that we're doing here is also to essentially anonymize this data. So when you get the data, you just get the data so you can do analysis, and you can do these somewhat sneaky things like trying to figure out who did it come from or where did it come from, right? So that's kind of the goal of this work. And so talked about security. One of the key things is that now with the proliferation of all these devices, whether it's CPU, FPGA, drives, NICs, whatever, you need to know, there are two things you need to know, right? See, these components that have firmware are posing an attack surface for the company that runs it, whether it's a cloud or an enterprise. And the key thing that any customer that's running any collection of servers needs to know is two things, right? Is this a legitimate firmware that's from the vendor that's supposed to be providing it, right? Was it modified in any way? And the second thing that they need to know is that, was it meant for me, right? Which could be legitimate, but it's not meant for me or for my environment. And both need to be answered for it to be valid. And that's the goal of a root of trust. Root of trust basically is the device that sits in the middle and makes sure every firmware that comes through answers those two questions. So from an OCP standpoint, we have our solution from Intel called PFR, Platform Firmware Resilience. That's what the PFR stands for. And it attests our BIOS and our BMC firmware images before it lets anything run. And we have the ability to detect the bad images and basically go back to a well-known state when we see that. It basically works so I have a pictorial that goes into a little bit more details, but I may not have the time to get into all of it. But it essentially intercepts the firmware accesses that are coming from the silicon and says, and measure the firmware and says, oh, this is meant for this environment, it's not. And we have open sourced our code at this point on GitHub. I have the link there. The slides should be available later, so you can go look at that, and so you can take advantage of the work that we have done here. And lastly, I want to touch on one of the more exciting pieces of work that's starting to happen for a few reasons, and I'll get into that. Right? Forever, we used to be on air cooling, right? Basically, you have fans and they cool. You have cold air coming in, hot air going out on the back, and that's how we cool the servers. And there are some limitations there, which I'll talk about in a second, that's making us explore alternatives to that. So the alternatives that are coming out are either it's a cold plate, where you basically send water through pipes to the components that run the hardest, or you do single phase cooling, where basically you're immersed inside the liquid, and the liquid comes in and then exits out, and the entire thing, you circulate the liquid, and then you exchange the heat from the liquid in a heat exchanger, and then thereby cool your system. So this is when you need a tank. And two phase, again, you need a tank, and similar to single phase, except that as the name says, two phase, the liquid is basically going from one phase to another. It's converting from a liquid to a gas form, and then it gets condensed back to liquid. So which means the two phase has to be sealed. It has to be completely sealed, otherwise you'll have liquid escape from your environment, right? So those are the options. So why are we looking into these things? Because one is edge deployments. One is because when we could design these nice data centers and put them in geographies that was perfectly ideal for air cooling or evaporative air cooling, everything worked out. But that's no longer the case when like the picture shows, it's a shed next to a mall somewhere. You can't control anything in this case, right? You can't control the temperature, you can control the humidity, you can control the pollution conditions. So you have to. So there the immersion cooling is starting to take effect. The other reason is that the fan power is basically proportional to cube of the airflow, right? So as you have to push more airflow, at some point it becomes it's diminishing returns in terms of what you get out of cooling with air. So then so when you start looking at immersion cooling, today I'm only going to talk about single phase immersion cooling. So the thermal performance, which is how well you are at essentially conducting away the heat compared to air, and any liquid in general is 10x better than air in terms of conducting, in terms of thermal performance. And thermal power density, you see the two pictures there, and you see the top one is a 2U system, and the same system is 1U once you design it for single phase, because in order for it to be air cooled, you need it to have a higher heat sink, and the heat sink basically pushes you to be a 2U height. So you get more density by going to immersion. And TCO, the total cost of ownership. The total cost of ownership improves for a few reasons, right? So it improves because, first of all, if you eliminate the fans, you eliminated the fan cost. If you change the heat sinks to a shallower heat sinks and the heat sink design, you reduce the cost of your heat sink. And if you eliminate the fans, then you eliminate the fan power, right? So, and then you also have infrastructure savings, because it's not just the fan, but the entire data center infrastructure, you're saving power. If you put it all together, that's the savings that you see. So you got, these are the considerations you need to have, and then you need to worry about, are the materials that you're immersing, are they compatible with the liquid that you're immersing in? And is the liquid going to sustain being in this environment for a sustained period of time, like 3 to 4 years, without degrading on you? And it's not just one solution, right? It's every geography, every government has regulations on what's allowed, flashpoint, what they're willing to accept. So you have to work in every geography. And then of course the safety factor of what's the toxicity of the liquid, right? What's the global warming potential? But and that also needs to be factored in. And then of course lastly is sustainability. Why immersion cooling helps sustainability is because when you're immersing, you're essentially reducing the power consumption of the entire environment, right? Because compared to the fan power, the power of driving a condenser is marginal compared to the fan power. So and also all the fans and the heat exchangers in the middle, you get rid of that. So that helps you a lot in here. And of course, the other thing is with immersion cooling, the rejected heat, you don't have to just release it into the atmosphere. You could potentially recover that heat for district heating or some other usage like it. So you have heat energy recovery from that standpoint. So these are the things that factor into it when you think of a immersion cooling solution, at least from our standpoint. So when you think of a solution, it requires multiple ecosystem partners to come together, right? First, of course, I'm Intel. You expect me to put silicon first, so I did. So and then there's the server platform, and the immersion tanks. They got to go in somewhere, right? So there are many vendors that make these tanks. The immersion liquids have to go in somewhere. And the immersion liquid vendors, you see Lubrizol sitting in the front seat. They make the immersion liquids. So it needs to go into some immersion liquids, and then they need to be compatible with all the stuff, right? You can't degrade some cable that's immersed in this liquid, right? And then of course the last but not least is you need to have warranty and servicing, right? So if you went to the expo hall, you see the robotics, because nobody wants to deal with putting their hands inside and servicing them. And then same thing, right? You want to be able to say, yep, I warranty these things for without any harm. So these all need to come together. So we are collaborating with the immersion liquid vendors such as Lubrizol and tank vendors to create this ecosystem. We have a demo playing in the Intel's booth. It's not manned, so that's why I call it a virtual booth, but you should see the demo there. And we announced the partnership with Lubrizol today, collaboration with Lubrizol to work on these immersion liquids that we are going to be looking at for single phase immersion to solve this very problem. And the OCP role is that, so you can talk, I talked about immersion tanks and liquids and silicon material compatibility, but there is an enabling angle to this role. That's why I'm talking about it at OCP. So the enabling role is that just like we have server designs that are put out here that people can reference and use, we need to have immersion cooling reference designs, right? That's a role that OCP needs to play. The other one is we need to have, somebody needs to track the regulatory compliance, right? What's right for Europe is not right for America, it's not right for Asia, depending on which country in Asia you're talking about. And as a central body that serves the world, I think it would be a great place for OCP to track that. And whenever we put out these things, we always say, no, my liquid has this benefit or sustainability benefit. My liquid reduces the power consumption by X. It would be great to have a neutral body like OCP to basically certify and say, yep, this reduces your power consumption by X, right? So with that, I will conclude with my call to action that, please get involved in OCP. Of course, we are at OCP, and engage with us on FSP and open firmware development, and engage with Intel and of course with AMI on the OpenBMC project. And come see our demo, talk to us, talk to Lubrizol on the liquids and on the immersion cooling front. And I think I'm just at the peak of my time. I think he's cutting me off. I can answer any questions. I'll stay outside. Thank you.